The graph of the parabola in x-intercept form is f of x equals a times x minus r times x minus s with some important features. So first thing, our axis of symmetry here is going to be x equals r plus s divided by 2. Our 0 over here will be r comma 0, and our 0 over here will be s comma 0. And our vertex will be at the axis of symmetry, r plus s over 2, comma, the function at that point. So plugging this x value into the function will give us the y coordinate at that point. So here we have x-intercept form and standard form, and they're equal to each other. This includes some important features. So the axis of symmetry is r plus s over 2 in x-intercept form, while it was negative b over 2a in standard form. Here, this root, r comma 0, is this. From quadratic equation, we have negative b minus the square root of b squared minus 4ac, which is the discriminant, over 2a, comma 0. So this is the x-coordinate of r. And the x-coordinate of s, the second root, is the positive version of this. See how this is negative b minus this? This is negative b plus this over 2a, comma 0. That's our second root. And finally, our vertex is going to be at the axis of symmetry. So using x-intercept form, that would be r plus s over 2. And then plugging that value into the function will give us the y-coordinate. Or we could do negative b over 2a, which is from standard form. And then we plug that value into the function to get our y-coordinate. All right, here we have some true or false questions based on this graph. So this is the graph of a times x minus r times x minus s. And let's begin with number 1. So we have the x value r inputted into the function, giving us this point here. The y value is 0. And when we input s into this function, we also get a y input of 0, or y output of 0. So 0 plus 0 equals 0. This is true. Moving on, we have r plus s equals negative 2. Now what we learned on a previous slide was that the axis of symmetry, which is here, because it goes right through the vertex, in this form is r plus s over 2. So we know that that equals negative 1 here. So r plus s equals negative 2 if we multiply this 2 to both sides. So r plus s equals negative 2. This is also true. All right, here we have the y-intercept here. When x equals 0, the y-intercept is at negative 2, which is true, which is also a times rs. Now, a way to see why this is true is to multiply this out. So let's move this up here. If I were to multiply this out into standard form, we would get a times x squared minus rx minus sx plus r times s, which gives us ax squared minus arx minus asx plus ars. See, this ars is right there, and it's also here. When we plug 0 into the function, that would make all of these x's 0, here, here, and here, eliminating those completely, leaving us with just this one term, ars, and that would equal negative 2, because that would be our y-intercept. So this statement is true. All right, we have now f times r plus s equals negative 2. As we learned up here, r plus s equals negative 2. So when we put negative 2 into our function, so here, negative 2x value, our y value is also negative 2. So this is also true. Finally, we have r times s is greater than 0. Well, r is going to be a negative value, somewhere between negative 2 and negative 3. So this is a negative number. S, however, is a positive number. So when you multiply a negative number times a positive number, this will actually be less than 0. So this one is false.